Hello, my name is Mustafa Düzok and I am a Senior Solutions Architect at AWS. Today, I'll be talking about the key characteristics of OpenSearch search score and ranking logic. I will also describe how different search queries and functions impact the ranking of the search results. First, I will start by explaining the different similarity algorithms in Amazon OpenSearch service. After that, I will discuss different powerful tools for fine-tuning search relevance through boosting queries, function score, and script score capabilities. These advanced features allow you to go beyond basic text matching, enabling the incorporation of custom scoring logic, business rules, and complex ranking functions into search results. Let's start with similarity algorithms in Amazon OpenSearch service. Text relevance in OpenSearch determines how well search results match a user's query. It measures the relevance of the returned documents in relation to the search terms. This is achieved with text matching and scoring algorithms. Text matching checks if query terms are in document fields. On the other hand, scoring algorithms rate each document based on the query term alignment, with the highest scored documents topping the results. OpenSearch calculates document scores using different algorithms. Term frequency, inverse document frequency, or in short TF-IDF, and Best Match 25, or in short BM25, are two ranking algorithms used in information retrieval. TF-IDF uses a simple linear approach to determine term frequency, assuming that relevance increases proportionally with the number of times a term appears in a document. BM25 employs a saturated frequency function for term frequency, recognizing that the relevance of a term does not increase linearly with its frequency. This approach prevents overemphasizing documents that contain a particular term many times. On the other hand, TF-IDF does not account for document length, whereas BM25 incorporates document length into its scoring logic. The choice between the two depends on the document complexity and length. TF-IDF is suitable for shorter documents and straightforward rankings. BM25 is better for longer, more complex documents and advanced ranking needs. Boosting queries are one way of fine-tuning search relevance in OpenSearch. Let's briefly see what it is. A boosting query elevates documents that match positive queries while reducing the relevancy of documents that meet negative criteria without excluding them from the search result. This method ensures visibility of all results while adjusting their positioning. For example, this query retrieves documents containing the word OpenSearch in the title, but reduces the relevancy of documents published before December 31st, 2022. The positive section specifies the main query, which matches the documents where the title contains OpenSearch. The negative section defines a query that matches documents with published date earlier than December 31st, 2022. The negative boost term is floating point factor, which is between 0 and 1, that scales down the relevance score of the documents matching the negative query. In this example, the relevance score of these documents are reduced with a factor of 0.15. Next, I want to talk about function score queries in OpenSearch. The function score query in OpenSearch allows you to modify the relevance scores of documents based on the custom functions, enabling more granular control over ranking. This is useful for incorporating additional factors like recency, popularity, and other field values into the scoring process. Let's look into this first example. The function score query modifies the relevance score of documents returned by the base query. In this case, the weight function is used to multiply the original score of each document by a factor of 2. This effectively doubles the importance of all documents matching the query. Using function score, you can apply different queries based on multiple conditions to assign different scores to each document. In this example, the first function boosts document containing OpenSearch in the name field, applying a random score and multiplying it by 2. The second function strongly boosts documents where the promoted field is equal to true, multiplying their score by 10. If any record falls in both queries, the max score is calculated for the document, because we have set the score mode to max. Documents with a final score below 0 are excluded from the results. Finally, I want to talk about script score function to fine-tune search relevancy. The script score function in OpenSearch allows you to customize the scoring of documents by executing a script for each document that matches a base query. This script can access the document fields, query parameters, and other data to compute a custom score. In this final example, the math.log function adds up the number of book reviews and comments, applies a logarithmic transformation, and multiplies it with the original relevancy score to increase the relevancy of documents, which have higher review and comments. To summarize, OpenSearch boosting queries Function Score, and Script Score provide a flexible and a robust framework for customizing search relevance to meet diverse application needs. Whether you are promoting specific content, applying business-specific ranking logic, or incorporating dynamic scoring based on your document attributes, these tools empower you to deliver highly tailored and effective search experiences. By leveraging these advanced query capabilities, you can optimize search results to align with your user expectations and business goals. Thank you for watching this video. You can now start applying different relevancy score techniques described here. Happy learning!